Okay, here's one of the most confusing yet important areas of this lecture: the actual descriptive statistics. Scoring information. Scores are derived from raw scores. So you've got your raw scores. Those are the numbers that you write in. So example, if you're working on a key math and a student misses a question, or rather gives an incorrect response, you write a 0 in the little box. The next question, they give a correct response, you give them a 1. So then you add up all the ones and zeros, and that is your raw score for that particular subtest. Now, then we start manipulating those raw scores. And it's called manipulation of raw scores. It's not like we're changing them in the base raw score. We're not changing that raw score. We're changing that raw score not from a 1 to a 2, but from one score type to another score type. And the different types that we are going to talk about are percentile ranks. I'm also going to touch on percentage because the difference is important and often it is mistaken to be the same thing. Standard scores we've already looked a little bit at. Grade equivalents, age equivalents, we've already looked at those. And then things like quotients. We're really not going to go into that in this lecture portion, but we will go into it at another time when it's more appropriate, because it's very rarely used. It's only used in a very few tests, and so you really only have to learn about the quotient. The quotient is equivalent to your overall full-scale score, but it's not on the same scale as, say, an IQ score, which is usually done on, if it's WISC, it's a 15 point range, and if it's the Stanford Binet, it'll be a 16-point range. But it's basically the same idea as that full-scale score. Now, but first of all, you need to understand the normal curve. Now, I'm going to show you a bell curve on the next page, but right here, you need to know just a little bit about it. Now, it's a theoretical construction. This isn't, you're not going to find a perfect bell curve in any one area of life. Again, it's theoretical, it's hypothetical. It's also, the bell curve is also called the Gaussian curve. And so when you think of, if those of you that are familiar with higher levels of math, the Gaussian curve has to do with much wider ranges of statistics, but we use it in education because it works very nicely. It's symmetrical, has a normal distribution, which is very important. The mean of the distribution is the midpoint of the curve. So that midpoint is always going to be on a range of 10. So it's going to be 0, almost always on a range of 10. There's 1 or 2 points where it's actually like a 0 or 1 or something like that. So you've got your 0, 10, 50, and 100 are the basic distributions that we're going to be looking at. Tails of the curve are infinite. So you're going to have a big wide curve at the very top, and then it comes off into at the 99th percentile at the very ends. We can't really say where it ends because we don't really know where that population data set is going to end. The mean of the curve equals the median, which equals the mode. Now, I know after discussing how the median and the mode are different, it's difficult to really explain that sometimes they are seen as the same. The area under the curve is measured in standard deviations from the mean. So the mean, this is actually where we're the most interested, okay? And you'll see what I'm talking about. Now, types of scores. We've got percentile ranks and percentage. Now, a percentile rank, that is all of the different ranks. So each score is ranked on a continuum of the normal distribution. And it goes from 1% to 99.9%, and 50 is your average when you're using a percentile rank. The person who scores at the 75th percentile scored as well or better than 75% of the students in that group. We're not talking about 0 to 100% on a test. All right? Now, the average of all the scores in a range are the percentage. Again, we're talking about the mean. So here's our example. Student A received an 87% on a math test, but scored in the 54th percentile on the annual I-STEP given in April. Student B received a 75% on the same math test, but scored in the 42nd percentile on the annual I-STEP given in April. Which of these students scored in the average range on the I-STEP? Now, this is actually a trick question, because they both scored in the average range. Because the average range goes from the 37th percentile to the 67th percentile, generally speaking, with give or take 1 percentile. So typically they are both in the average range. So when you're explaining this as a teacher, you're explaining this to a parent when they come in with their I-STEP scores, and they're going, I do not understand this. Johnny is just doing so terribly in math. And you're like, well, actually he's in the average range. But he got a 42%. No. He is in the 42nd percentile. And that's when you need to explain to the parent what the difference between a percent and a percentile, and yes, they're going to be confused at first, but when you will also have a graph that you can show them what you're talking about. Now, which is having more difficulty with the tested math concepts? That is an easy one. That's simple math. Whoever got the higher score is doing probably better. I mean, that is usually the way that we look at it. So student A would be doing better on those tested math concepts, but they're both in the average range. Now, let's talk about z-score properties. We're going to kind of go about this a little bit backwards from the least important to the most important. Now, a z-score has a mean of 0. So, here we are, right here at 0. That's also where you're going to have your 100 score, your 50 score, and so, but the important thing about z-scores is we use it as a way of determining the position in the single score curve, okay? Now, we use it in standard deviations. Now, the standard deviation is a very important concept in education, because that is how we generally, if we're using the weight to fail method, which most schools, districts, even though they're not supposed to be, that's the method they're still using. If you're using that gap, you're going to have 2 standard deviations from your mean. So, this is where you're going to be looking at. This is where your average student is at. This is where that student with learning disabilities is going to be hitting. So 1 standard deviation is about 68.26% of the population. So this is the area that we're looking at. 2 standard deviations is in the 95th percentile. 3 standard deviations comes out here, and we generally don't look at anything past that. Now, a t-score, here we can look at these, all right? A t-score is a type of score that's mathematically transformed. Now, all of these scores have been transformed from the raw score. You need to remember that. Now, here's what we're going to do with the t-score. Here we have our standard deviations. So remember, these are z-scores. Then we have our cumulative percentages. Okay? Then we come down here and we look at our percentile. Again, we're looking at the 50s. Z-scores, again, we have them rated right here. So really, we've got it listed twice, as a standard deviation and as a z-score. Now we're down to our t-scores, which is, again, on a scale of 50. So 50 is your average score. So you're going to find your t-score. Say we have a t-score of 53. Okay? So this is 50, so this would probably be about 53 right here. Now you know that it has an average of 50. You look at the very center of the curve and follow it down the row for the t-score. So here we are, and we're going to come down here and we're going to find our t-score, and it's going to be at about right here. And then you know that t-scores have an average range of 40 to 60. So then we're going to look at here. So 40 to 60, here's our average range, and it matches up perfectly with the percentages and the z-scores. They all match up perfectly. It's about 68% of the population would score in that range. The bell curve never changes, and neither do the distributions. Individual scores change, but the bell curve will not change. Now, I've brought our lovely little scale over to look at the stanines. Now remember, right here were the t-scores. Stanines are standards of 9. Okay, they just put in a little bit different, and this is the only score that comes with a 5 as your central score. Okay, and the mean is you're going to have standard deviations of 2 or so. Now stanines, where do we use those? We also use those in educational testing. You'll see those on the I-steps. You probably won't see them anyplace else. So then you're going to be having, they come in at, and this is the way that they do it. The first 4% is at the first stanine, the second, and all the way up. When you get to the mid-range, or the 5, that's where you're going to find 20% of your population. Now, if you look, here it is. We have to split them in this area. So it's not a very clean kind of score manipulation. It's not nearly as clean as having it on a scale of 10, which is why a lot of times we don't use the stanines as often as we might use some of the others. Now, finally, we have deciles and quartiles. These are the least used of all of them. Deciles are divided into groups of 10, with 10% belonging to each decile. So in the highest decile, you would have 100%. The lowest, you would have 10%. It's very, very simple. Quartiles are divided into 4 groups of 25% each. They are each rarely used. But I wanted to give you kind of an overall picture of what each of these can be used for.